Alright, Math 3 classes. So, you guys should have these same notes, but just because you have them already written down doesn't mean you should blow them off. So let's pay attention, make sure we're filling out the examples so that you guys know what's going on with each one. Basically what I'm going to do is talk about a few concepts, then we'll take a look at the examples and talk about them. So we're kind of doing one at a time. So if you need some extra time to write stuff down, to copy it down, make sure that you ask the guest teacher to pause the video so that you guys can stay caught up. Alright? So we'll start pretty simple first off. And I guess this really isn't on your notes, but there's one thing we need to talk about. It's called the fundamental theorem of algebra. Okay? And it basically says this, that the degree of your polynomial tells you how many zeros you could have. Okay? Okay, how many x-intercepts, how many solutions for x, how many zeros that you have. Okay? So, if we take a look at our first practice problem, so this one right here, okay, if I look at it, it looks like we have 3 x-intercepts, 3 zeros. So most likely my degree is a third degree polynomial, okay, an x cubed, something else. Now that doesn't necessarily mean it has to be x cubed, because we do get into the sticky situation where we could possibly have some imaginary numbers. We're not really going to deal with those, so let's just kind of go with the lowest possible number, which would be a third degree polynomial. Okay, so if I look at number 3, okay, we have this, which you would probably want to say looks like a third degree polynomial, but there's something else we're going to have to talk about with that. So let's head back to those notes. So x-intercepts, okay, it's where it crosses or touches the x-axis. Okay. We also have the y-intercept where it crosses or touches the y-axis. Okay. Two simple ones. Remember, x-intercepts are also called zeros or roots. Y-intercepts are always called y-intercepts. Okay. And remember, the whole reason we call them zeros is because if you're solving the equation, you set it equal to 0, so you change the y value to 0, and these are the answers you get. So let's kind of talk about these degrees and the x and y intercepts together. Okay, let's head back up to 1. Okay, we'll come to the other ones. So the y-intercept and x-intercepts are pretty easy to tell, right? They're points. So first one would be -1, 0. The second one would be 0, 0. And the third x-intercept would be 3, 0. And the y-intercept would also be this 0, 0. Okay, pretty simple. All right, now if we get to number 3, okay, I'm going to tell you right now, you want to say it's a third degree. It's actually a fourth degree polynomial. And our x-intercepts, they look like this. So we've got -3, 0. We've got 1, 0, and 3, 0. Okay. Now there's something interesting that happens. Oh, and y-intercept is down here at 0, -2. Okay. Now there's something that happens if we go back to this one with zeros. Okay. Remember how we talked about if we're solving something like this. Let's call that 2x and 1. Okay. You would factor it, right? This is normally what you did last year. Oh, that should be a 1. Okay. And then you'd set them each separately equal to 0, and that would be your zeros. So if I look at these zeros and I work backwards, okay, it's like x equals -1. Well, if I add 1 to both sides, I get x plus 1 equals 0. And I would get just x equals 0. And I would get x minus 3 equals 0. And if I wanted to, I could then find the equation by taking these and multiplying these together. Okay. Now, what we run into is if we look at number 3, okay, Notice that this goes straight through and crosses. This also crosses, but this one only touches. Okay? That keys you into something we call multiplicity. Basically, we can have a 0 that is more than 1, okay, that we count twice. And that goes back to this idea that if I were to take this, x plus 1 times x plus 1, that's really x plus 1 squared. Okay? That number right there on the factor, that determines your multiplicity. Okay? Now, just like with degrees, we said an odd and an even degree have different properties. Well, an odd or an even multiplicity here tells me it's got a different kind of way of crossing or touching that x-axis. And basically the rule is this, okay? And so maybe we should go back to our notes. And so you may want to write this on the side somewhere, but with x-intercepts, I'm going to erase this part right here so that I can write it down. You want to probably write it down on the side or top here. With multiplicity of zeros. It's not with the y-axis, it's only with the x-axis, the x-intercepts. Okay? If it's odd, it crosses through the x-axis. If it's even, it touches. Okay? And we will talk more about multiplicity and kind of play around with this a little bit more. But basically, the higher the odd number, the more it's going to cross, but it's going to look flatter. It'll look more like that, but still cross. Okay? Whereas with even, the higher it gets, the just flatter it gets when it touches. Okay? So, if I'm looking back here at the problems, okay, these ones all cross through, so they all have a multiplicity of 1. Okay? Could they have a multiplicity of 3? Yeah, maybe, but they're crossing it pretty steep, so that would be a 1. You'd see like a jog in it. So 3, because I have one that's touching, that's going to have a multiplicity of 2. So the way I just can mark that is I'll just put m colon 2, telling us that this 0 has a multiplicity of 2. Okay? So if you kind of still don't get that, that's all right. I just wanted to introduce it today, and then we'll talk more about it. All right? So if we look at question number 5, okay, now looking at this one, notice that we've got a 0 here, but it touches. A 0 there, but it touches. Okay? So I'd go, my 0 is negative 4 is 0, and it's got a multiplicity of 2. Okay? That means that if I'll show you in a second. Then we have 0, 0, which touches, so it also has a multiplicity of 2. And then 4, 0, which touches 1, so a multiplicity of 1, which I'll just leave it like that. The y-intercept, pretty easy to see, 0, 0. Now what that means is if I change those to factors, I'd have x plus 4 squared times x minus 4 times x squared. And just because it's an x, it could be squared on the inside or the outside. And later we'll look at how we can take this information from the zeros to help us figure out what kind of problem we're dealing with. But instead of saying this is a third degree, that would actually be 2, 4, 5. It would actually be a fifth degree polynomial. Okay? It's odd because of the shape, and we can see that because of those zeros, how many it has. All right? Okay, number 6 or 7. Oh yeah, because the way I did it, right? All right. So the degree here, see, we've got 1, 2, 3 that we see. So I've got negative 3, 0, which, because it crosses the way it does, looks like it's a multiplicity of 1. Notice how this one, though, is still crosses, but see how it flattens out more? So at negative 1, 0, we'd have one, and that would be like a multiplicity of 3. Okay? And then at 4, 0, we have one that touches, so a multiplicity of 2. So if I add these multiplicities together, 2 and 3 is 5, and 1 is 6, tells me I've got a 6th degree polynomial. Okay? And then a y-intercept of it looks like about 1/2, 0, 1/2, huh? 0, 1/2. Okay, so there's kind of a basic idea of those zeros, how they help us understand what the graph can be, and how we understand when it has those differences other than just crossing through it. Okay. Alright, now we're going to take a look at our relative maximums and minimums. Remember, basically it's just when we get the curves. Okay, and they're relative because our graphs usually continue going down or back up. Okay, so the maximums and minimums are points again, and so they're pretty easy to see. And I have no extra weird stuff like with the multiplicities. So if we take a look at our graph here, okay, we should see I've got a minimum here, and let's kind of estimate. So I'll call that -2, -9. Then it looks like we've got another minimum right here. We'll call that 2.5 and about -1.5. And then we have a maximum right up here. So that would be 1, 0. Oh, maximum 1, 0. Okay, so minimums and maximums, pretty straightforward. Let's take a look at number 1. Okay, so minimums again, that looks about to be 2, -6. It's only got one relative minimum, and then a relative maximum looks like it's -0.5 or -1/2, and we'll say 1. Okay, we'll kind of estimate there, just so we get the main idea where it's at. Alright? Okay, and taking a look at the other ones, you should be able to do these ones as well. So minimum looks like right about here, we'll call that -2.5 and -0.5. Okay, now you may say maybe there's a min or max there. It's only going to flatten, but it never goes up or down, so we don't call that one. I've got a minimum here at my 0, 4, 0, and then it looks like we have a maximum right up here. We'll call that 2.5 and about 5.5. Okay? And then back up here, okay, we've got two maximums here. Okay, we'll say -2, 2, and 3, 9. We'll estimate those. And then two minimums at my zeros, right? -4, 0, and 0, 0. Okay, so those are really probably the simpler aspects of these graphs, because they're all points. Okay. Now for the next four things, we're going to deal with increasing, decreasing, and positive and negative. Okay. Alright, so in order to talk about increasing and decreasing and positive and negative, okay, increasing as we look left to right, going up, okay, decreasing, going down. Positive is when the graph is above the x-axis, negative is when it's below, okay. So in order to do that, we're going to use what we call interval notation, okay. They talk about open and closed intervals. Basically, if the number you're using is part of the answer, okay, you use brackets. And what it stands for is from this point to this point, x sub 1 and x sub 2 are points. That's where it's increasing or decreasing, or it's positive or negative. Okay. If you use parentheses, it's when it's not part of the answer. It's kind of like with x is greater than 5. If we graph that, we go to 5 and you draw an open circle because 5 actually isn't part of your answer. But it's the barrier, the boundary of your answer. Whereas x is less than or equal to 5, okay, we go to 5, it's part of the answer, so you'd fill in the circle and then shade. Kind of the same concept. Okay, so this is the hardest part. Isn't necessarily saying when it's happening, it's writing it down. Okay, I think on the graph we usually can see increasing, decreasing, positive and negative and all that. The trick is trying to understand how it's all working together. Okay, so let's take a look at those ones. Alright, so if we're talking about increasing, okay, I'll do that blue. So increasing, right, as I go start left to right, and the further the graph goes this way, we always call that negative infinity. The further it goes this way, we call positive infinity. But if I look at this, these are the sections where it's increasing as I look left to right. Okay, as I start over here and look to the right. So how do I write that? Well, it's starting at negative infinity. I do a parentheses, it's open essentially because you can never reach negative infinity. And so I start out here at negative infinity and I'm traveling until I hit boom, this maximum, right? That x value of the maximum. So it's increasing until it gets to negative 1/2. And that's part of it increasing, so I use brackets. Then it's going to jump a section, right? Oops, too far. Starts here and jumps down here to start increasing because right here, this is where it's decreasing, right? So it's decreasing from that negative 1/2 until it gets down to what we called our minimum 2. Okay? So that's the section right here of my graph where it's decreasing from x value to x value. Then it's going to start increasing again. So I put a little u here, and we start at 2, and then it's just going to keep increasing as it goes up to the right. We call that infinity, and that's what my increasing and decreasing would look like. Okay? So let's do that for all of these, and then we'll go back and do positive and negative. Okay, so again, this time it starts up high, so it's decreasing till it hits that minimum, then increasing till we hit that maximum, decreasing again, and then increasing again. Okay, so the way I write that, decreasing, we start clear to the left, we call that negative infinity. So I start negative infinity until I hit this minimum, which we called negative 2, and then it jumps up to that maximum, which was 1, until we hit that minimum, which was 2.5. Oh, yeah. Okay, so we end with that, and that's telling us all these sections here where it's decreasing. Okay, so these are just like x values because we use it just like a football field yard line. Okay, on a football field, doesn't matter where you get tackled on the 50-yard line because you're always on the 50-yard line. It's the same concept. We don't care where it's at here on our interval. That's just the section of the graph. Okay, so increasing, we start where we left off, so at negative 2, and then it goes to 1. It's increasing, then it jumps and starts again at 2.5 until we keep going to the right. So we call that positive infinity. Okay? All right, so number 5. Okay, now this one, we've got decreasing here, then here, then here. So this time we've got 3, don't we? So we start out at negative infinity because it's the furthest left till we go to about negative 4. Then it jumps up to negative 2. And then it goes down to 0. And then it jumps one more time. And it starts up at 3. And then it goes to positive infinity. Okay, so A, B, and C represented A, B, and C. So for increasing, we kind of fill in the holes, right? So it's increasing right here. So we say negative 4 to negative 2, it's increasing. Then it jumps to 0, 0. And it's kind of in between here, so it's 0 to 3. And there's our increasing. All right. So number 7, okay, same idea. We're increasing, we kind of flatten, but not enough to say we're not increasing in that section. So I could say we start out increasing at negative 2.5 until we get to 2.5, we called that. Then it jumps, and it starts at 4, and it just keeps going to positive infinity. So for our decreasing, it starts out at negative infinity and goes to about negative 2.5. Then it jumps, and it goes from 2.5 until we get to 4. So between increasing and decreasing, you should go from positive to negative infinity. Okay? Now let's take a look at positive and negative. Okay, we'll do positive green, negative red. Now, positive is simply above the x-axis, So here, clear to here, till it crosses, then it crosses again. Okay, so the only part that's negative is right there to there. Okay, the x-intercept to x-intercept. But we use function notation the same way. So positive, we start clear out here at negative infinity. So negative infinity until we get to right there, negative 3. Then we jump until we hit 1. Now, technically when it touches the x-axis, it's not positive, but we're not going to get that nitpicky. So it keeps going until it gets to positive infinity. So it's negative simply in that smaller zone, so in between here and here. So negative 3 to 1. Okay? Alright, so negative here is basically just right here, isn't it? So that would start out at positive 4, and it would go, as we go to the right to positive infinity, it's going to keep going down. So that would make negative, or positive from negative infinity here until it hits that 4. So we'd go negative infinity to positive 4. That one wasn't too bad, was it? Okay, now if we look at 3, you can see positive up here from negative infinity until we got to negative 3. Then it jumps and it starts being positive from 3 to positive infinity, which would mean negative is at negative 3 to positive 3. Okay, then number 1. Okay, we start out negative, then go positive for a little bit, then negative again, and then positive again. So we'd start out negative from negative infinity to negative 1. And remember, with these intervals, we're only dealing with the x variables, okay? Only with the x. Then we're going to jump and start at 0 until we go to 3. So for positive, we start there at that negative 1 to 0, then it jumps negative, so then back to positive at 3, and then it goes till positive infinity. Okay, so now we've only got one more to deal with, and that's end behavior. So with end behavior, we've talked about this one. Odds and evens give us something different, okay? Basically, we're asking, as we go to the right or to the left, now what's happening to the y values. With end behavior, we now care. Okay, now, there's a few different ways we can write it. One way we see it written is, we call it the limit. Okay, the limit as x approaches infinity, and this is more like a calculus format of doing it, of f of x, that's the y values, what is it approaching? Positive or negative infinity is usually the two that we go from. Okay, so then left end behavior, as the limit as x approaches negative infinity of f of x equals c. So notice the only difference is positive or negative infinity. To the right, positive infinity. To the left, negative infinity. Up, positive infinity. To the left, negative infinity. Now, I gave you some other notes to kind of help us see it, and I gave it to you in different formats because sometimes some people like it a certain way. So we noticed that when the degree, n, the degree of the polynomial was odd, okay, it had a different shape to it than when it was even. So I like this because we don't, with end behavior, we don't care what's happening here in the middle. We just care the ends. So if it's odd and this coefficient is positive, so you can write positive here for the coefficient and negative here. Okay, so if it's odd and positive, as we go to the right, it goes up. So the limit as x approaches infinity of our function goes to positive infinity. As we go to the left, we go down, negative infinity to negative infinity. If it's odd but then negative, it just flip-flops it. So as we go left, it goes up to positive infinity. As we go right, it goes down to negative infinity. So remember, with odd, you have one going down and one going up. And positive or negative determines which side. Okay, now for even positive, okay, they're both going positive. As it goes to the left or to the right, it's going up. If it's negative, they're both going down, okay? So another way we've seen it written is kind of like this. Okay, f of x approaches what as x approaches what? So as x goes to the left, the y values are going up. As the x values are going to the right, y goes up. Okay, you can also see it written this way, okay, with the same idea, okay, of the even, positive and negative, odd, positive and negative, okay, same thing. All right, so end behavior, okay, as I go to the right, it's going up. As I go to the left, it's going down. So I don't care which way you write it. So you can write it, the limit as x approaches positive infinity of my function f of x, it's going to equal, to the right, goes up, positive infinity. So this, as it goes to the right, it goes up. Then you can say the limit as x approaches negative infinity of my function, so as x goes to the left, it's going down. Well, down we call negative infinity. Okay, so that's how I write end behavior. Now, if you can't quite figure that out, and if at first all you need to do is something like this, and say as my graph goes to the right, it goes up. Okay, as we go to the right, it's going up. As I go to the left, it's going up. And we go left, up. For this first little bit, if that's how you write it, that's all right. Another way you could write it, as x approaches positive infinity, as x goes to the right, f of x approaches positive infinity, f of x goes up. Or as x approaches negative infinity, as x goes to the left, f of x goes up, or to positive infinity. We probably should try to get to the point where you can write it like that and understand it like that. But if for right now you can only do one of these two, I'm okay with that too. All right, so number 5, okay, end behavior. As we go to the right, we're going down. As we go to the left, we're going up. So we know it's a odd degree, and we also know it's got a negative coefficient. But how do I write that? The limit as x approaches positive infinity. As we go to the right, our function goes down to negative infinity. Okay, right and down. Going the other way, the limit as x approaches negative infinity of my function. As we go to the left, we're going up. So we go up to positive infinity. So the concept is actually pretty simple. It's just the way we write it down that makes it more complex, which is probably half of the problem with doing these key features. Okay, last one. So once again, it's even, so they're both going up or down, and it's positive because they're both going up. So I can write as x approaches positive infinity, f of x approaches, so as we go to the right, we're going positive infinity, or up. As x approaches negative infinity, as we go to the left, our function is also going up. Okay? So there's those ones, guys. Now, you may notice you had another page of notes here, right, after we looked at that. Okay, a few things I don't really care so much about it, but you have symmetry. So if it's symmetric to the y-axis, you can fold it over the y-axis. If it's symmetric to the origin, that means you can kind of rotate it around and get the same thing. Okay. If it's symmetric to the x-axis, right, that would be something like this, which typically we don't see with functions. And then if it has no symmetry, which most of these ones don't, because there's no way, the way we've done them, there's not really a way you can make it symmetric. So that happens in only a few cases. That's why I don't talk about it a whole lot. But most of these wouldn't have symmetry. But that is something to pay attention to when you're looking at this stuff. Okay? All right, guys. So there we go. So you've got some notes. You've got a small practice assignment. You should have plenty of time to work on that. There will be a video up on that if you want to check it. If you guys all get done in class quick enough, you can have your guest teacher show you that, and you can check your work. Other than that, there we go, guys. Graphing polynomials.